since 2001, RE squared has certainly made a name for itself in the industry. So what do you think that is attributed to?
I think RE squared success and the reason why people know us is that, well, we've been around for 20 years, but I think one of the reasons we have been around for 20 years is that we always do what we say we're going to do. There's many times where we've had to even sacrifice profitability in order to deliver what we promised. And I think that's key is if you sign up to do something, the customer always comes first and you solve the problem no matter what it takes. And because of that, we have customers that keep coming back to us to solve problems. And in fact, we have customers from 15 years ago. And that makes me very proud. And secondly, I think we're one of the few companies that has been able to innovate as well as produce product all under one roof. We're not a large company, but somehow the ilk of the person has that innovative approach, but also has that pragmatic approach that can transfer it into product. And customers know that we can solve really hard problems and then provide a really reliable product on the back end.
Yeah, that's a great point. And oftentimes when I'm talking to customers and clients, many are surprised initially to learn that RE squared has this whole production capability as well. Could you speak to that a little bit around how we not only can produce highly innovative, like more or less proof of concepts, but also transition those proof of concepts into actual product?
Yeah, I mean, that's RE Squared's goal is to be the #1 provider of human-like robotic capability. In order to achieve that, we have to put product into the world. And that's exactly what we're doing. And we've been doing it since 2010. We started with Northrop Grumman, their Andros HD-1 robot, 181 robotic arms were shipped to Air Force Explosive Ordnance Disposal. And since then, we've shipped over 625 robotic arms to the U.S. military and commercial customers. And I think what's amazing about our production capabilities is we have a very agile in-house group of people and machinery that, when coupled with a network of qualified contract manufacturers, allows us to do really small jobs as well as to quickly ramp up to shipping hundreds of units in a short time frame. And all of our contract manufacturers are within a 300-mile radius, meaning that all of our robotic arms are made in the USA, and I'm pretty proud of that.
So maybe jumping topics here for just a bit. We talked a lot about kind of the origin story of RE squared. Now I want to talk a little bit more about some of RE squared's specific capabilities. And when you think about RE squared and our general capabilities, oftentimes I think one of the areas that RE squared is probably best known for is our robotic arms. Why do you think that is?
So in 2005, we really decided to focus on robotic manipulation because we saw a deficiency in the market. In particular, we focused on mobile manipulation from day one. So we were not focused on the factory floor. There's plenty of robots since the 1960s performing that function. By focusing on the mobile aspects, we started from the ground up looking at size, weight, and power. And those were the main design drivers that created a unique capability. And I think that's why we're best known for our robotic arms.
So is that what you would say best separates RE squared's capability from a lot of other players in the market?
Yeah, by focusing on size, weight, and power, we generated robotic arms that were truly human-like. That means that not only were they strong and dexterous, but they were also compact and lightweight, producing unprecedented strength-to-weight ratios. Additionally, these arms were designed to be used for mobile platforms, which meant that they were very power efficient They were able to deal with shock and vibration, typically experienced on mobile platforms. And lastly, in terms of human-like, they were able to go anywhere on the planet. We could go to Greenland, or we could go to the Sahara Desert, and we could operate in weather. We could operate in any temperature. That was a unique capability that was generated by focusing on building a human-like type of robot from the beginning.
Yeah, it's funny you say that. So when you talk about operating anywhere on the planet, I think many people are often surprised to know that RE Squared also makes underwater robotic arms as well. Could you talk about some of the origin story behind our underwater arms and that capability?
Yeah, so 2005 is when RE Squared really focused on building arms for terrestrial use, and the military was the early adopter, but now they're used equally in commercial applications. So, because since 2005 we've been developing mostly terrestrial arms, most people think of RE Squared in that vein. However, in recent years, RE Squared has adapted its human-like capability from the land to the sea, where we've replicated that human-like capability underwater. And we've tested them in shallow and deep depths within the ocean. And the result of this adaptation is what we call our Maritime Dexterous Manipulation System, or MDMS. And we're continuing to push this technology farther, going deeper in the ocean, as well as adding additional dexterity. That's true of both the arms as well as the hands. In fact, we're working on a program right now for the Navy where we're developing a conformal hand that can be used for our underwater arms. And that conformal hand mimics the way that a human hand works. So it conformally grasps objects to provide a secure grasping, which is particularly important underwater.
Jumping topics once more into another realm of capabilities within RE Squared, I wanted to talk a little bit about our intuitive human-robot interfaces. So why do you think human-robot interfaces are important? I mean, aren't robots supposed to perform a lot of tasks automatically or autonomously?
Oftentimes, you want a robot to perform a task, and maybe that task is dangerous, or and you want to keep the human out of harm's way. But you still need the human intellect to perform that task. The explosive ordnance disposal, perfect example of that. We have arms that are at Fukushima helping with the cleanup. Another example of where you don't want a person there directly interacting with the physical environment. But you still want to have the human in the loop to teleoperate that system and perform complex tasks, because many human tasks still require the human intellect. AI is continuing to advance, and there are many applications which are structured enough that allow AI and computer vision, etc., to be utilized. The factory was one of the first applications. But no matter what, you'll always need a human-robot interface to allow the human to, if nothing else, check in on how an autonomous system is doing, or in many cases, directly teleoperate that system.
And so I think one of the trademarks of, or one of the key aspects of RE Squared's human robot interface is that it's very easy to use. Why do you think that it's important that a human robot interface is extremely easy to use?
Well, if you're looking from a teleoperation standpoint, or for an autonomous system for that matter, an arm is really only as useful as your ability to control it. So for an arm to be effectively teleoperated, it needs to be seamless, that interface between the human and the robot. That robotic arm should feel like an extension of the person controlling it. And we've experimented for the past decade with many different ways of interfacing with robotic arms. We've looked at joysticks. We've looked at 3D mice. We've looked at Microsoft Kinect, computer vision hand gestures, uh, dials and knobs, voice control. And what we came back to every single time was our imitative controller. And what it is a scaled model of the arms that you're controlling. And however you move that scaled model is exactly what the remote arms, the physical arms, do in tandem. And we found that this is a highly intuitive method of controlling robotic arms. We measure intuitiveness in two ways. One is training time. It only takes about 1 minute to train someone on how to use this system. And secondly is time to proficiency. With about 2 hours of stick time, you're able to perform some pretty complex tasks. For example, if you look at our highly dexterous manipulation system, HDMS, which is a two-arm system that emulates a human. Each arm can have either 5 or 7 degrees of freedom, and it usually has a torso plus end effectors. A person using the imitative controller can be controlling a 16 degree of freedom HDMS within hours and performing very complex tasks such as opening a duffel bag using that system. And that's how we know that we've achieved that intuitive interface between a human and the robot.
So is that imitative controller, I guess that mirrors the kinematic layout of a robotic arm? Is it only good for controlling a robotic arm, or what else can it do?
No, the imitative controller extends beyond the robotic arms. They can also, given that at the ends of the imitative controller are these what we call flight sticks with a lot of inner buttons and switches that your most dexterous digit on your hand can utilize, which is your thumb, you can perform a lot of system level tasks even from this system. So just as a human, if you were to walk through a doorway, you reach out with your arm, grab the door, you open the door, and then as you're going through the threshold, you're moving your legs and opening the door and holding it at the same time. So we're able to control the mobility aspect in addition to the arms all at the same time. So we're almost viewing whether the arms are mounted on wheels, on tracks, or on legs, we're able to control the mobility part of the system at the same time as we are the manipulation part of the system. And additionally, beyond the imitative control, when you look at a human-robot interface, you also want to have a good graphical user interface feeding information back to the human. And because when it moves beyond the teleoperated and moves more into a supervisory role where they're overseeing autonomy, you still have to have a good insight into what the system is doing and why it's doing what it's doing. So a good human-robot interface is critical to know what's going on with the system, as well as when you're teleoperating it, to do so in an intuitive manner.
Since 2001, RE² Robotics has remained committed to our mission to develop innovative technologies that make a positive impact on the world. RE² is a leader in the design, development, and manufacture of human-like robotic technology, solving the most challenging applications in the world. If you would like to be contacted about a robotics application, please email us at myrobots@re².com. That's myrobots@re².com. To stay up to date with the latest RE² news, visit our website at www.re².com, or you can always follow us on LinkedIn, Instagram, Facebook, and Twitter. If you'd like to see more videos like this, or videos featuring actual RE² robots, please subscribe to this channel on YouTube.